In our previous demo video, we took a multimodal approach to measuring engagement in Mario Kart. The study looked at engagement through somewhat conscious behavior, facial expressions, and non-conscious behavior, blinks. In this video, we will look more into engagement with 5 sensors: eye tracking, ECG, respiration, facial expression, and voice analysis. Welcome to an iMotions demo. Continuing our exploration of engagement, I hypothesize that part of what makes Mario Kart engaging is that it is full of surprises. In this study, I wanted to look at emotional reactions to surprise crash events. First, I labeled crash events with an analysis tool called markers. Some players have many crash events and in quick succession. Some have long stretches between crashes. To make labeling these events more efficient, iMotions markers can be assigned to a key, and the replay screen can be adjusted to your workflow. I watched the screen capture videos at double speed, paused with the spacebar, customized my skip interval, and used arrows to skip to the exact event. This meant I could annotate the recordings, keeping my hands on the keyboard. If you prefer to use only the mouse, or a combination of both, you can also do that. There are 2 types of surprises in Mario Kart: the ones the player could not see coming, like lightning strikes, and the ones the player might have been able to see. Once the crashes were labeled, I wanted to know if the player saw the obstacle before the crash event. By obstacle, I mean items like an incoming turtle shell or banana peel up ahead. To do this, I needed to track these objects and the player's attention to these objects. I used iMotions Auto AOIs to create areas of interest, a crucial eye tracking analysis tool. Because the obstacle is often moving, either toward the character or the character is moving toward it, with normal AOIs, I would have to indicate where the object is in every frame. Auto AOIs creates an AOI very close to the size and shape of my object with just a few clicks. Once I found my objects, I looked at the eye tracking data to measure the player's attention to these objects. I could automatically create data annotations using auto annotations based on the AOIs I had created. This automatically creates annotations that show when the player was looking at that object. Now, I've labeled the crashes. I tracked attention to the obstacles to see if the crash was likely a visual surprise. I expect a surprise to have a strong visceral reaction. Let's take a look. For a jump scare, players can have a very quick drop in heart rate, often followed by an increased heart rate. We might also notice a gasp or holding breath in the respiration data. These are the criteria I use to see if there seemed to be a strong change in arousal. Remember the auto annotations we discussed earlier? I can also use auto annotations to annotate a specific interval of time before and after the crash. In this case, I can indicate a time interval of 10 seconds and focus on respiration and heart rate events in this time period. If the person crashed, did not see the obstacle, and then gasped or experienced a change in heart rate, I can pretty confidently conclude that the player was surprised. Knowing which crash events were surprising, I could use this information in many ways. I might compare surprise crashes to crashes that are not surprises. I could characterize which items induce the most intense surprises. I could see if the number of surprises correlates to how players self-report feeling about the game. I chose to look at emotional expressions after the surprise crash. How do players react? With facial expression analysis, I can see surprise expressions or more complex facial expressions after a surprise. Voice analysis gives me verbal exclamations and transcribes what they say. From this, I can get an idea of whether there were more positive or negative emotional expressions in relation to crash events and have a more nuanced understanding of engagement while playing Mario Kart. In this demo, we saw examples of using 5 sensors to have a deeper understanding of what is surprising and quantify how surprised players are. We detected complex emotional reactions that give us a very different perspective of engagement than the simpler metrics in the previous video. Not all research questions require such extensive multimodal analysis, but having advanced tools that can support your exploration of more complex behavior means that you can continue being a creative researcher without compromising on quality data.